Hello and welcome to the video entitled Solving Systems of Equations Through
Elimination.
This is Mrs. Reynolds and
Mrs. Bear.
And we are here to help you. Okay, so how do I do this, Mrs. Bear? I don't even know how to do this.
Actually, elimination is the easiest method to solve systems. It's faster than substitution and graphing, so you're going to like this. If you take this first system, elimination means I want to eliminate one of the variables, either x or y. So do you think that we could add the equations together or subtract them in order to eliminate x or y as it's written here?
I feel like we could subtract them because I see 5x, and we could subtract, if we subtract the bottom, then at least we know we'll get rid of the x's.
Yep, that's exactly it. So I'm going to take and rewrite the system here. And you should answer this question here based on what you just heard Miss Reynolds saying.
Yeah, with a complete sentence, right?
Yes, a complete
Not
sentence
just
would be
circling one
good.
of the two things, which is what I'm guessing.
So if we subtract 5x, take away 5x, there's no x's. 8y, take away 6y is 2y. 40, take away 32 is 12. Now I can divide both sides by 2. Oh, 8. Thank you, Ms. Reynolds.
That's okay.
I'm going too fast. And I get y equals 4.
Awesome. So I'm done. So y equals 4 and I'm done?
No, you still have to find out what x is. So now I need to take this value of y and plug it back into one of these equations and find out what x is. Which equation do you think might be faster or easier to use to plug back in? Do you have a preference?
I prefer number 1 because it has an even number. They both have even numbers, excuse me, because it has a multiple of 10.
So you just think these numbers look easier to work with?
It seems easier.
It does not actually matter. It's totally your choice. I'll go with what you said, and we'll plug it in here. So it becomes 5x plus 8 times 4, because y equals 4, so I'm plugging it in, equals 40. That gives me 5x plus 32 equals 40. Subtract 32 from each side.
I like how you show the steps so well.
5x equals 8. Divide both sides by 5, and x equals 8/5. So my answer is x is 8/5, y is 4. It is okay to get fractions in your answer. I know sometimes we feel like we made a mistake if there's fractions. If you're feeling like you made a mistake, you should stop and look back over your steps again, because like you saw me do, it's easy to make mistakes.
Right. And
so
don't
that's
use
the first one.
Don't use a calculator, guys, in my class. Be sure you don't get tempted by that, because I want you to I actually want you to do it like this so you can keep it in fractional form.
Yep, my class too, no calculators, please. So Ms. Reynolds, if you look at the next problem, problem number 3,
okay.
Do you think it would be easier to use addition or subtraction if you solve this one?
Well, I think addition, because you already have a nice, neat little zeroing out thing happening here.
Exactly. A positive 5x and a negative 5x are going to cancel when we use addition.
Perfect.
So you should write a complete sentence saying what you thought. If you had a different opinion than Ms. Reynolds, then you should explain what you were thinking. So I'm going to write down the equation, which is really similar to the last problem that we just did. I'm going to warn you, the numbers are not so pretty in this one, but I'm going to walk you through it. So
Yeah, it's good.
I'm going to add them. These zero out. That gives me 14y equals 74. Divide both sides by 14. Y equals 74/14, which reduces to y equals 37/7.
Nice.
I'm going to take that and plug it back in. I'm just going to use the top equation.
Okay.
And again, you could have used either equation, but I'm just going to use the top one. 5x plus 8 times y, which is 37/7, equals 42. I'm going to make that a fraction. That gives me 5x plus 296.
Jaden Williams, please report to the library. Jaden Williams, please report to the library.
Lunchtime announcements, folks. So that gave me 296/7 equals 42. I'm going to subtract this from both sides. Now I know I'm going to need common denominators to do the subtraction, or maybe turn that into a mixed number first and do the subtraction. I'm just going to make 42 over 1. I'm going to just multiply by 7 on the top and bottom. I'm just going to keep it as improper fractions. I just felt like it was faster that way.
Yeah.
And that makes 294 sevenths. Well, 294 sevenths, take away 296 sevenths, makes negative 2 sevenths.
Nice.
Now I need to divide by 5, but if I divide both sides by 5, this is a fraction. We don't really divide fractions, we multiply by the reciprocal. So instead, I'm going to do that. These cancel and isolate x. I can't cross cancel here, so I get negative 2 35ths. Can that be reduced?
No.
No.
That is a messy
That is not a
problem.
pretty one at all.
But it was still fun.
Oh, fractions. They're so much
It's
fun.
so much fun.
Shall we do one more?
Can we do one that has, which one are we planning on doing? Because I would like one that we have to multiply up or down. Do we not have that?
I think we do that on the next page.
Oh, the next page. Are we gonna, oh wait, we can just end it here and then, are we gonna do one more?
We'll stop.
Okay. Bye everyone.